All right. So I guess it's about the top of the hour. Welcome, everybody. Thank you for joining us on the last session of the day or of the fest. If you didn't know, we're here to talk about the new Mover plugin. I'm Justin Hare, one of the engineers on the project. I've kind of been with it since the beginning, along with a handful of other people here and there. Let's get to it. So what we're going to talk about today, we're going to keep it mostly high level. We'll dig down a little bit into some networking details, but I'm going to talk about why do we even need this thing? What's wrong with the old one? What is actually inside it? Some details about the main concepts in it, how it's put together, how it operates. And I think it's worth pointing out some of the differences in the network replication model and how it operates, so you can get an idea of the consequences of how things are different under the hood. As you may know, it's still an experimental plugin. It's not done. There's plenty of things that are wrong with it or left to be implemented. So we'll go over some of those. Hopefully, give you some idea of whether Mover is right for you or your project at this time, and then also talk about stuff we're working on in the near future, so you have an idea of what's coming next and when when those sorts of things might land. And if we have enough time, I'll do Q&A. But if we run out of time, I will totally be at the Dev Hub afterwards for a couple hours. Okay, so let's launch into this. So why do we even want a new character movement system? What's wrong with the old one? Well, based on a lot of feedback from people who work on Fortnite and people who post things on forums and submit comments to our product board, it comes down to a few key areas. Number one is like the complexity of the system. It's a very steep learning curve if you want to go in there and make changes. It's very easy to just fire it up. It works. There's a lot of stuff that just works right out of the box, but it can become a little bit cumbersome to extend and make changes to it. And when you do, you kind of have to become an expert on not just how is this capsule moving around in the world, which is largely a math problem, but all that stuff gets tangled up in networking replication, rewind, resim, smoothing out changes, all sorts of stuff. So kind of a high bar. You also kind of chain to some rigid requirements that not everybody likes, which is you have to have a character actor type, which is a pawn. So if you wanted to do movement with other kinds of actors for your project, you have to start with a character, which has a lot of built-in baggage with it. It also makes some underlying assumptions, which is your shape is a capsule. It may shrink, it may grow, it may get wider, but it's largely just a capsule moving through the world and tends to want to just stand straight up. So that doesn't really work if you want to do crazy things like you might want to lie down on the ground and have a very narrow thing. You may want to make a dog character or a horse or something that doesn't really fit into kind of humanoid shapes. The networking model, while it works really, really well, it's kind of like bespoke. It's just built for itself. It's sort of like in its own little world. It doesn't interoperate with other systems very well. Like one common complaint we get is like its replication and rollback is completely independent if you're using like the game playability system. So they have a tendency to not jive perfectly well together when network conditions are bad. And when you do want to go and extend the system, it has to be an engineer to do it. It requires C++. Typically, it requires a lot of inheritance, virtual function overrides, that stuff. And if you are working on some kind of game where you, like a live game where you might have little modules that you pull down and you want to add new movement modes at runtime, lots of luck. You got to come up with your own system. the character doesn't support it right out of the box. So you're kind of locked in at compile time. So the answer to all this stuff is the new Mover plugin. Like I said, it's an alternative to CMC. I will say CMC probably a lot today. Just that's always talking about the old character movement component. But it does away with a lot of these rigid requirements. So you can slap the new mover component on an actor of any type. It doesn't really make any requirements of, does it have to be a capsule? It could be some other shape, a box. You could even put together compound things if you wanted to. You're still responsible for implementing movement for whatever crazy creatures you want, but the door is open to you to do that, and you don't have to worry about the replication side of things. Things should just work. Modular design is another one. So movement modes are now objects, and a lot of the other things can be added and removed at runtime. You're free to eject anything from kind of like our default movement set. If you don't want to bear the burden of having this many properties involving swimming on every character, taking up memory, just kick it out. You don't need it, and you don't have to pay for it. The rollback networking. So there's two flavors inside the Mover plugin. The first one we implemented was using the network prediction plugin. Has anybody heard about that one before? Cool. So basically, it is a separate system, also developed at Epic, sort of like a generalized rollback simulation framework. So you can build, it allows you to build systems on top of it for that style of networking. And it handles all the details of transporting data from between clients and server when there are rollbacks. It handles all the details of that. So largely, you can just focus on, based on my current state and a time step, what should my new state be? Which, that's 99% of crafting movement. The other flavor, which I'll talk a little bit about more later in the deck, is the chaos networked physics. So that's something that's become a lot more mature and capable lately. So there's a whole effort, some folks on our physics team, we've been working really closely with them. If you've seen like Lego Fortnite, you've seen a lot of our physics, networked physics systems advancing and showing up in products that we've launched. So now we really want to make unlock the power of a physics-based character networked, and we're doing it by kind of smashing the two systems together. And both of these systems open the door to deterministic simulation, which was something that was not possible with the old system due to just the nature of how it's kind of firing moves between client and server. So latency, network jitter, all that could affect the order of operations that happen on the server, and ultimately how well it syncs between clients and the server. So new system, but we didn't want to like throw everything out and do something unfamiliar to people. CMC has been around for 20 years. Lots of people are using it. So we wanted to make sure that people who are familiar with the old system could jump into the new system, bridge to it, and still be pretty productive pretty quickly. So to that end, we have this, what we're calling kind of a legacy movement set. I think it's actually called default character movement set. It's basically just has a lot of the same functionality and settings exposed. So if you just use that, it tends to behave nearly identically to CMC. But you don't have to use it at all. It's just there is a bridge if you want it. Okay, I had to insert this slide because I think there is some confusion around floating around. So character and CMC are not going away anytime soon. We have not announced plans for that. Mover is still very much experimental. And we'll talk about what exactly that means in a little bit. But if we were going to get rid of character in CMC, sunset it, I mean, this is a cornerstone system. Tons and tons of licensees rely on it. So we would declare probably a very long and clearly defined timeline for if we were going to deprecate it or stop supporting it. But there's nothing in the plans for that now. And we still maintain it. If there's bugs, we fix it. But not a ton of like new feature development going on there. Additionally, Mover, before we say something is no longer experimental at Epic, typically we use it ourselves. We use it in one of our products, which ships, it goes out into the world, and endures, millions of hours of gameplay before we say, okay, we'll stand behind this, and we're pretty sure it's going to work for you guys too. So that's another bar that needs to be hit. We just released this thing in 5.4 a few months ago. So it's just hit the community. We're getting a lot of feedback. If you guys do play with it, we love hearing from you about pain points and all that, and we're trying to incorporate that into our development plans. We also love hearing about bug reports and pull requests if anybody has improvements they'd like to see. Like I said, we're a small team, so contributions go a long way for us. And I did want to say we don't have a target date yet for beta. Okay, so I got a quick video here, and I'll kind of talk over it to talk about little bits. So this is just a collection of some examples, stuff we've done with it so far. So this is kind of showing how modes can be added modularly. So in this case, I think we're adding a swimming one, and then you'll see how the settings related to swimming would get kind of added dynamically. And just a handful of demonstrations of common mechanics. That was another thing people had a lot of complaints about, like, how do you do this stuff in the old system? How does Fortnite do it? We get questions like that all the time. So it was very important to me to provide a lot of examples along with what we ship. So this stuff is in the Mover Examples plugin, which comes along with UE. This is an example showing how a mechanic is set up in Blueprint as far as authoring input and then affecting the simulation with it. Another project you may have seen around, Project Titan. They were kind of one of our first customers for this. They're kind of an open world exploratory project. They were able to take the system, Sebastian's one of their engineers, and he prototyped these movement mechanics for this, trying to get through this huge space in interesting ways. So they were able to craft these things quite easily. He said he had a lot of fun with it. So things like gliding, grappling, everybody wants grapple. So now we can show people how to do it. Even this crazy walk thing that you can kind of float around in the water, or you can slide down hills on it, sort of like a sled. Very fun. And I'm sorry you're missing out on the presentation, which is also going on right now, but our animation team just released this awesome animation sample that features a lot of motion matching animation. So it came out, and last week I was like, hey, I could really quickly adapt this and convert it to use Mover instead. And so I did. So this is just a video captured off of my dev station. But basically, Mover and motion matching really go hand in hand. I think I'll talk about why that is in just a minute. So primary Mover concepts. So these should be kind of familiar if you've been using Character Movement Component or CMC. Movement modes are very much the same. Things like walking, falling, climbing. There's only one ever active at a time. It can generate proposed movement and separately executes it. And you can switch between them either kind of on an immediate mode where you can switch in the middle of simulation, like if you're falling and you only use half your time before you hit the ground. you can switch to walking. There's also transition objects, which are kind of an object way where you can write queries or logic that evaluates it at runtime. And then layered moves are also pretty interesting. They're very similar to root motion sources, which we use kind of extensively for a lot of things, where dashing and homing melee attacks and things like that. You can also use it for jumping if you want to. But basically, these are things that they're typically temporary, but there can be many of them active on your character at once. Typically only one or maybe two, and they can each generate their own kind of velocity. And all these velocities get mixed together or override each other depending on settings and priority, and it all gets fed into whatever the active movement mode is to actually execute, to actually push your character through the world. And maybe most important, the biggest change is this composable inputs and state. So rather than having to do a bunch of inheritance and defining override structures at compile time, here you can add your own project-defined structs. It's basically kind of whatever you want. As long as you can net serialize it, you could theoretically put it as data in an input or state. I should, if it isn't clear, like input is something that whoever owns that character would create. So like the autonomous proxy would author that. It gets sent to the server, and both systems would simulate the movement with it. So, and state is kind of a snapshot of your character's simulation state, location, maybe velocity, orientation, whatever your project needs. And these things can also change at runtime. Like I said, if there's a different movement mode that comes in and it just has some extra data attached to it, it can be thrown in the mix. Other notable features. So mode transitions, I talked a little bit about that. I did want to make sure that was clear. Those are also UObjects, so those can come and go dynamically. They can either be attached to a specific mode if you're looking for like exit criteria, how to get out of that mode. It could also be something global, something that's evaluated all the time, like if it's some kind of an environmental trigger. I think I used it for an early version of zipline, and if I happen to get close to a zip line, it would detect it, set me into ziplining mode, and away we go. Proposed movement versus executing movement. This is pretty important. Basically, there's a really hard, clear line between the things that generate movement or velocity. This is where we want to go, regardless of like what you're actually going to run into. You start with, here's where I'm trying to go. And then the mode that actually executes it is responsible for interpreting that. And that actually allows us to do things like the look-ahead queries that are mentioned a bit lower. So that's where things like motion matching come in. So if I have a clear difference between proposed movement, that actually makes it easy to predict movement without actually triggering it ahead of time. So we can fake what the inputs would be, maybe even fake what the state currently is, and we can generate paths that accurately represent the path that the character will take, as long as it doesn't, hit anything or get interrupted. And that's kind of the basis for motion matching, where you're trying to use both the history of where you've been or what pose you're in, and looking for a trajectory. Where am I trying to go? And then you try to find an animation that you have that matches that future path as best as possible. And yeah, you can get really good visual results with that. Animation root motion as an equal citizen. So in the CMC, whenever there's animation root motion going on, it's like that's the only thing that goes on. You can either have that active, or you can have controlled movement, or root motion sources, so programmatic versions. but you could never have them mixed. It was always one or the other. Here, animation root motion will come in just as another layered move, so you can take that and blend it with your controlled motion or whatever else is going on. It's up to you. I mentioned the mover examples plugin as well. Like I said, I have a strong focus on, we use it to verify that our work is done. We use it for regression testing. If some of our changes tend to break things, it's a lot easier for our QA teams to just jump in to our examples and verify something. Similarly, we do have like kind of a test-only plugin, which is it might be a little boring, I'll be honest, but it does have like kind of automated stuff that you can fire up and run. And maybe last but not least, as we are crafting like the default character movement library or the movement set, we're trying to, rather than just have big chunks of monolithic code, movement code, like in CMC, we're trying our best to kind of break that out into blueprint libraries so that you can use those same functions for things like, pushing this a shape through space, figuring out how it should slide along a wall, go up slopes, that sort of thing. So you can use those to craft your own movement, and hopefully even do it in blueprints to a large degree if you want. So let's talk a little bit, let's do kind of a comparison. I know we touched on some of these points already, so I'll go a little quick over them. Modular versus monolithic. That's sort of one of the key things, as well as we don't really care what actor type you have. We don't care what kind of shapes you have. I think the only requirement is you have a root scene component, which is just a point in space. It doesn't have to be a primitive. If you just have a point that and you want point-based movement, you're free to make that yourself. So unified rollbacks versus isolated rollbacks. Okay, so now we're getting to the more interesting part. So in CMC, I say isolated rollbacks. It's basically if you get a correction to your movement, your character rolls back maybe to a different position and replays some moves, sort of in isolation. So none of the other characters that are on your machine, or at least the versions of them, are moving. They're frozen in space wherever they happen to be. With network prediction and somewhat with the physics, it's a little more complicated. Everything rolls back together. So if there are other characters really close by, they will also roll back to their state that you're rolling back to, and everything gets replayed again together. So the benefit of that is you're much less likely to have repeated corrections necessary. It's usually one and done. Also, corrections are no longer detected server side. The server just is always trucking, and it's still the authority. It's broadcasting state to everybody, and it is up to the clients to decide, do I need to reconcile with the server and trigger a rollback and resimulation. We've also kind of locked down, we've made clear what exactly is the state as far as like the simulation, of the character or actor. And it's sort of blocked in the old system. Like there's a lot of just public blueprint writable properties, even velocity, like sort of like maybe the most important variable is just open. Like anybody can write code or blueprints that just directly touch it, directly modify it. So it's open to crazy town. So the new system it's more naturally guarded against those sort of things. And you'll get warnings if you do have systems like moving your character outside of the simulation. It'll be detected, and you'll get some warnings. So move cadence driven by the server. In CMC, how a character moves, even on the server, is largely determined by how fast that client is ticking. So if you've got an awesome machine and you're running 120 frames per second, depending on your project, you might actually be trying to send a move 120 times a second to the server, while your opponent has a lesser machine and is only sending 30. So when all those things arrive at the server will actually, try to move you the 120 FPS person at a much finer, faster, granular rate, whereas your opponent is sort of tick, 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 more chunky. With Mover, with the network prediction plugin, all of these things are unified. So we're buffering inputs instead. So the server has its clock. Everything is syncing to that clock, and the inputs are kind of consumed at the same time. One of the downsides, of course, not very tested compared to CMC, which has 20 years of life in Epic projects. It's very battle hardened. It works really well. It supports Fortnite and other games. So we got that not going for us, but hopefully we'll have some stuff out soon, and it'll become better a lot very quickly. And one of the coolest things, network physics support. So in CMC, if you've ever tried to run into a physics box, you're either going to get kind of a believable reaction, or the box is going to fly off into nothingness, and you don't really know what's going to happen. So supporting the physics system natively is a big advantage. So now we're getting into the dirty stuff. So I'll go over this pretty quickly. So this is comparing CMC's replication model with the network prediction version. So I just want to highlight a few key points. I have kind of mentioned it, but start with like the ticking model. So in CMC, it's the client ticks and the client time that's driving the simulation, even on the server. It just kind of has to be resolved. So it's kind of a weird setup, bespoke for character movement. Compare that with network prediction. Both the client and the server are sort of trying to tick together, especially if you have like you have it set to fixed tick simulation, but they're sharing the same concept of simulation time. And the client is just running ahead of it. And then input. So in CMC, we send kind of a combination of inputs as well as results. So it's basically like, hey, I tried these inputs to try to move at this speed, and here's where I ended up. And then the server tries the same move and compares the results. In network prediction, instead, we just send the inputs. We never tell the server, hey, this is where I ended up. Instead, the server holds onto those moves in a buffer, and that's important to note as well, and then consumes them when the time is right. Each of those inputs has an associated simulation time with it, so that's how it knows when it's time to consume them. And then in the old system, the server is responsible for detecting errors, mispredictions, and it alerts the clients. In the new system, all it does is broadcast state out to everybody, and possibly inputs to the simulated proxies. And it's up to the client to detect errors, possibly reconcile things. So it's sort of a shifting of responsibilities. Hopefully it's a little bit lighter on the server. Okay, so let's talk a little bit about the physics side of things. First, possibly most important thing, when we're using chaos network physics, we are not using the network prediction plugin. It's sort of like we have a switch. You can choose one or the other. You can live in one world or the other. Fortunately, they do have a very similar networking model. so that it still has the very same concepts of clients authoring inputs being buffered, error detection and resolution being handled on the client. It's also kind of by default an async simulation, so you put all that movement, all the movement operations, everything. It's off the game thread on your physics thread, operating like that. It does have some consequences though, so that the physics thread is always operating a little bit ahead of like where you would see the character. Your movement would happen on the physics thread before your character catches up to it smoothly. And that's so we can have smooth movement in between ticks. And also same thing with corrections. So instead of necessarily, we have some options, but you don't necessarily have to like rewind and resim. You can also just instead accumulate error, and then the physics system kind of slowly erodes it over time. So you got some options there. So a little bit of video on this. Don't try this with CMC. It will not work well. Our physics Manny really hates boxes for some reason. He's very aggressive with them. And even on things like dynamic platforms, things perform pretty well. I don't know if you noticed the foot IK kind of helps keep the character planted even though the platform is kind of moving. So it kind of opens up the door to new gameplay mechanics. You can see like momentum transfer is pretty accurate. And this is my favorite example that kind of ties everything together. We've got two networked characters. The entire bridge is a networked physics object or set of objects. And we can even do things, kind of pushing up. And everything kind of like behaves reasonably. It looks cool. And I don't know. I think people are going to have a lot of fun coming up with new gameplay that just wasn't possible before. Let's see. Okay. So now the bad news. So things that are kind of still in the works. Some problems we've run into. Like I said, so the system's still very new. We haven't shipped anything with it yet commercially. So there's a few things we still have to figure out. One big problem, and this is network prediction specific, is the siloed ticking. So the way network prediction works, all these objects, it wants to always tick them in the same order. So that can become a problem when you want to do things like based movement. So, or you might have a movement platform that's sliding back and forth and your character's jumping around, but once he lands on it, now, if you don't have the order of operations right, you'll see the platform sort of be moving off by one, and you'll see the foot sliding whenever it changes direction. So that was a little difficult to get working, and I suspect it'll cause other people some problems as well. The big thing, I think, this is my most hated bug. We don't yet have interpolation of locally simulated objects. So what I mean by that is I personally want to run movement simulation at a fixed tick rate, but I want my render rate to be variable. I want to run at 144 hertz on my favorite monitor, but still run the movement simulation at 30. And that will help, that'll match what's on the server. I can keep server costs down and still have deterministic simulation between the two. But currently we don't have a natural way of smoothing what you see, basically the presentation where I'm seeing the character. So if you have that, you basically see the character movement feels a little chunky compared to like the very smooth camera movement, which is operating at the 144 rate. But that's something we're going to have fixed very soon. Boilerplate code. So if you want to add your own custom structs for input or state, there's still a little bit of C++ required to define those structs. So you can't do everything in Blueprint yet. I think that's probably the biggest thing, but hopefully we'll get a solution for that soon as well. Scalability and performance. Hasn't we haven't tried to scale it up to battle royale sized cases yet. I suspect it's just the nature of the networking model will probably be a little bit more bandwidth heavy. So that'll be something we need to evaluate. And I do know personally of a number of kind of low-hanging fruit things on performance, not only CPU but also network bandwidth. Interactions with non-simulated objects. Yeah, so network prediction has basically puts your moving actor sort of in its own little world. The ticking thing comes into play here. So if you have objects that are moving separately on the game thread through like a classic some other method of movement, it can be difficult for those things to be perfectly synced. And it gets worse with physics as well, because your movement sim is can be up if the simulation is 30 frames per second, your physics state can be 33 milliseconds ahead of what people are seeing on the screen. So if there's something that is not physics based, you could have penetration or something. Finally, there are a lot of existing systems in UE and probably in people's projects that just assume, hey, our only option was to work with a character or a character movement component. And so now I've got this actor that isn't any of those things, but we still want to do things like motion warping, AI, and navigation. So what we're finding is we're having to go back into some of those systems, refactor them a little bit so they are more flexible on the type of actor they're working against, or provide some sort of interface or adapter, so we can expand those possibilities. Okay, so looking forward. So right now we are looking forward to 5.5, but we've also got, some of these priorities will be beyond that. Obviously, physics-based characters, that is a huge priority for us. It's something that is a big company priority, not just on our team, but we want to unlock this sort of stuff for like our UEFN developers. If they can go in and say, instead of a regular island, we can create a physics-based island. They can go make a physics-based gameplay, whatever that would be. So the physics system is a little bit more experimental even than the regular part of Mover. It's all still coming together. So we do have a lot of work both in supporting all of the concepts that Mover provides in a physics world, especially things like events, since we have everything running on a separate thread. And that has implications for gameplay integration as well. We don't want you to necessarily be accidentally writing gameplay code that's not thread safe. So we're trying to figure out what the best way of doing that is. And so all of this, we're trying to reach parity with everything you can do with network prediction. Hopefully you can also do that with your physics-based characters. So that is all going to see a lot of progress, I think, really quickly. Animation support is also big for us. The animation team has a lot of really ambitious goals, and we're already starting to see the results of that with the new animation sample. So motion warping is very huge. I don't think that made it in for 5.4, but it is done. So I don't know if you get the Git version, then it's there. Similarly, expanding trajectory queries. Right now, it's very simple. If you can, from wherever your character currently is, you just say, where's he going to be in 1 second from now, and give me 30 samples. We want to expand that so we're not only kind of predicting the trajectory, but a pretty common use case will be like, we also want to do some kind of light collision test. So like the animators want to provide anticipatory animations. Like if somebody's running and they're about to run head on into a wall, it would be great if they knew ahead of time and they had something in their animation set where they could brace the character for impact. Yes, and improving, just in general, improving animation root motion. I don't know if you noticed, the keen observer might have noticed as we finished some of our root motion playback, it doesn't blend smoothly back into controlled motion yet. So that's a big one for us. Overall, cleaner simulation. Right now, there's a little bit of coupling between what we consider the simulation state and the actor. So when in the default character set, if you are using walking mode, it is actually moving the capsule, but we don't necessarily need to do that. We could just do the math and not move anything until the very end. And once we achieve that, we can do things like, possibly multi-thread movement. So it should open up a lot of doors. And I already mentioned, fixed tick sims with variable rendering rate. I'll say no more on that, but I'm looking forward to heading back home and working on it. Maybe on the plane. We'll see if they have good Wi-Fi. And as far as the default character movement set goes, it's kind of rudimentary right now. It's pretty good, but there's some missing settings. I don't think we have a full-fledged swimming mode yet, and there's some settings that are just not at parity with the old system. And we want to do some more examples as well. So like we have the concept of arbitrary gravity, but we want to be able to actually show it off. And of course, one of the things everybody wants, like, I need a character that is not a capsule. So we want to provide examples of that. So all these things will be coming shortly. So awesome. I'm headed to the Dev Hub. Come see us there afterwards. I'll be hanging out for a while. Thanks.